Hello, and in this video, I'm going to teach you sigma notation. So to start, this symbol right here is called sigma, and it basically means sum of. Now let's start by looking at everything around the symbol. So over here, we see something that says j plus 2, so let's write that down. J plus 2. Next, we see something right over here. It says j equals 4. So that basically means that j is going to start off as 4. And finally, up here we see the number 6. So this basically means j is going to end as the number 6. So j is going to be equal to 4, then it's going to be equal to 5, then it's going to be equal to 6, and then it's going to stop right there. 6 is going to be its last value. So now that we have all the values j is going to be, we're going to plug them in to this expression. So let's start with j equals 4. We're going to get 4 plus 2, that's just 6. J equals 5, that's just going to be 5 plus 2, that's 7. And j equals 6, that's going to be 6 plus 2, that's 8. And then we find the sum of all these terms. So we're going to have 6 plus 7 plus 8. Now here, we notice that this, right here, is an arithmetic series. It starts off as 6, and then we add 1 to get 7, and add 1 to get 8, so it has a common difference of 1. And that's basically what sigma notation is. Sigma notation is just going to be a condensed way of writing out a series like this. So now let's find the sum. 6 plus 7 plus 8 is just going to be 21. So our answer is 21. Now let's try another example. This time our expression is 3k minus 1. Now k is going to start off as 3, and it's going to end at 7. So our values of k are going to be 3, 4, 5, 6, and 7. Now let's plug these into our expression. 3 times 3 minus 1 equals 8. 3 times 4 minus 1 equals 11. 3 times 5 minus 1 is 14. Then we're going to have 17. Then we're going to have 20 if we plug in 7. And then finally we find the sum. 8 plus 11 plus 14 plus 17 plus 20. This time we have another arithmetic series where our starting value is 8 and our common difference is 3. Now if you find the sum of these numbers, we're going to get 8 plus 11 is 19, 14 plus 17 is 31, so we're going to get 70. So that's going to be equal to 70. Now let's do one last example. So for our final example, we have the expression 5 times 2 to the power of n. And we're told that n starts as 1 and ends as 3. So we're going to have 1, 2, and 3 as the values for n. Now we're going to plug them in to our expression. We're going to get 5 times 2 to the power of 1, 5 times 2 to the power of 2, and 5 times 2 to the power of 3. This is equal to 10, this is equal to 20, this is going to be equal to 40. So now we're going to have 10 plus 20 plus 40. Now notice that this time, this is going to be a geometric series because our starting value is 10 and each other term is 2 times the previous term. So this is just to show that sigma notation can be any series, not just an arithmetic series. Now the sum of 10 plus 20 plus 40 is just going to be 70. So our answer for this is 70. Thanks for watching.